Hi, welcome to the Intro Stat lecturing series. And we are working on this unit. It's called the testing hypothesis. And this is our lecture number 1. In this lecture number 1, basically, this is the introduction lecture. We're going to talk some basics like a definition, the terminologies in the statistics here. Okay, so now let's go ahead and go to our lecture notes here. Okay, so the first things we want to take a look is, in the statistic area, we have two branches of the statistics here. One is we call it is descriptive statistics, and another one is we call it is inferential statistics. So in this course, we're going to cover both descriptive statistics and inferential statistics. And for the descriptive statistics, we're going to use some software to help us to do it. So let's take a look at what is the descriptive statistics. Okay, so let me see here. So the descriptive statistics here. So let's take a look. What is our definitions here? Okay, so the descriptive statistic is, we said that the keywords here is we organize and summarize the data. So you want to know something, so you go ahead, you go to collect the data, right? So after you collect the data basically just what? It's just a bunch of numbers, right? Without organize, without summarize it, and the data are just some numbers. They don't tell you anything. So the descriptive statistics basically say, hey, let's try to organize, summarize how to change those numbers into what we call the information, right? So we want to change the number to the information, and then we can use this information and try to help us to make some decisions and to draw some conclusions here. Okay, so basically the descriptive statistic is like after we collect the data, how do we organize, summarize the data, and change a bunch of numbers into some very useful information. So there are two different ways we can summarize the data here. So the first ones here we said is like we can do graphing. So we say the graph, is very, very good because we can, like, for the people, if they don't know the meaning of some statistic, they see the graph, they will be able to, they will get some ideas, and you almost can see, like typical, we see a pie chart, bar graph, almost, a lot of magazines. When you flip, open the magazines, you always saw, you always, you see those charts, those graphs. And then the next things here is beside the graphs, sometimes you want to use numbers. That means you kind of summarize those numbers. And so like the numbers we use, for example, is like the average. So we say, what is the average? What is the maximum number? What is the minimum numbers? What is the variations, right? So that's what we mean by the numbers here. So that's what, this is a big branch in the statistic area. We call it descriptive statistics, how to do that. And because right now we are in the, the time, we generate, we told, we sometimes call it big data set, right? So it's a lot of data there. So in order to be very efficient to do that, of course, there are many different softwares, even Excel, you can do it, right? So in here, for this course, we're going to basically cover this branch of the statistic. We're going to use, we call it the software code is the R. So R is, we call it the open source software. That means everybody can use it and it's free, right? So we're going to use R to help us to do some graph, because when you use the software to generate a graph, it's a lot easier to do instead of you spend like so much time to dealing with thousands like the data points. right? So we're going to use R, and this is part of what we're going to talk about, in the lab part, going to show you how to use R and how to do the pie chart, for example, how to do the bar chart, and how to give you summary about your data set here, right? That's what we call this descriptive statistics. Then the next branch is here, we call this inferential statistics. So what is the inferential statistics here? Okay, so let's take a look at the inferential statistics here. So here is what we to do. Okay, so the inferential statistics basically tell you, we say, hey, I'm using the probability, okay, to determine how confident we can be that our conclusions are correct. All right, and so that's what is the inferential statistics. So for example, you said, I was wondering what are the for the Dallas area, let's say the private university, when the students, we accept the new students into the university, what are their average GPAs, right, from the high school? What is the average GPA from the high school? We will give the admissions. So you can go ahead. So that's why you go to collect the data. Then you say that, oh, I think the average GPA probably is from the 2.8 to 3.5. So that's what we mean the inferential. You summarize it, and then you draw the conclusion. Then people say, oh, how do you know? Then you can say, well, I'm kind of, I'm pretty sure, right? So when you say I'm pretty sure, how sure is that? You say, I'm 95% sure. Okay, for example, I'm 95% sure the average GPA when we get the freshman in is kind of between 2.8 to 3.5. That's what we mean. The statistical inferences here is, I'm going to have associated probability to tell me how much confidence I have to say that. All right, to draw the conclusions here. That's what we call this inferential statistics here. And this is another big area. So for example, I want to try a new drug to, to treat like the certain disease. Like we said, the drug A and the drug B here, right? So then I will give different groups of the patients to use drug A and a different group of the patient use drug B. Then we will compare how many people cured by using drug A, how many people cured by drug B. Then I will say, hey, the drug A is better than the drug B because I have more people cured. And from this experiment, that's what I'm drawing because I'm collecting the data. Now I'm drawing the conclusions here. But am I 100% sure? No, maybe the next time I do the experiment, if I take the wrong sample, maybe I will have a different results here, right? So every time when you draw a conclusion, statistics is not absolute, right? So it's always have uncertainty there. So that's why we say, hey, I think drug A is better than drug B. It's kind of like, I think maybe, I'm pretty sure, maybe 90% I'm sure that A is better than B. Right? Okay, that's what we call this inferential statistics. And other things you can draw, the idea is like you say, hey, I think a number of hours studies, right? So number of hours you study, and hey, what is your grade for the final exam grade, right? Okay, so final exam grade. So you can see I can collect the students, they study different hours. Like some students study only 1 hour, some students study 2 hours, some students study 3 hours. Then I will see what is their final grade. Now I want to see, is there a relation, right? So how much confidence I can conclude if you study more, you get a better grade. All right, so that's what we call this inferential statistics here. So after you summarize, after you graph your data, then I want to base on my statistics to make decisions here. Okay, so that's why in here we say effective interpretation of the data. That's what we call this inferences here. So you make a conclusion. is based on the good procedure for producing data and the thoughtful examination of the data, right? So you want to, that's why, you know, when you just collect the data, you leave the data on numbers, we really cannot get a useful information. So that's why we want to organize and summarize data, right? Then based on this, then we can draw the conclusion. And then when we draw the conclusion, I want my confidence about my conclusion, of course, is as big as possible, right? So that's why we say it's associated with the probability to determine how good you draw your conclusions here. Okay, so this is a two branch of the statistics. Like, you know, we divide it, we call it descriptive and inferential here. Okay, so the descriptive in this course, we're going to be part of our lab. It's part of our lab work. We're going to take a look. So first, of course, we're going to give the basic like lecture about what is a pie chart, what is a bar chart, what is the means, right? And then we're going to use software to help us to do that. And then the inferential statistics is a very fun branches also. So it's how do we draw the conclusions based on my data here. Okay, so before we even start to do it, so now I want to, the next things here is I want to introduce some basic terminologies here, all right? So I'm going to introduce some basic terminologies, the statistics we always use. So when, you know, later you see in all the other lectures, you will hear I say population, statistic, parameter. What that means here, okay? So let's take a look at the first, what is the population here, okay? All right, so let's take a look at how do we define the populations here, all right? So we say the populations, okay? So the population is the collections of all the objects under the studies here, right? So the key word here is everything is under the study. In statistics, you know, we general want to study is the populations here because I'm curious. So it depends on what you are interested, right? So if you are interested, say, hey, I want to see all the college students in the Dallas area, then your population is what is pretty big, right? So that will be all the college students, right, in the Dallas areas here. So now if you say, hey, I'm only interested in the students from the University of Dallas to see what is their average GPA when they, you know, like in here, when they, you know, when the time they graduate, right? So then your population shrink to what? It's a University of Dallas here. Or if you say, hey, I want to see the family income, you know, the average family income for the whole Texas. Wow, then your population is pretty big, right? That means it's all the families in the Texas. And you like to see what is the average income. So that is the whole population, right? So if you say, hey, I'm only interested to see what is the average income for the city of Dallas, right? So then your population will be every family in the city of Dallas. But still it's pretty big, right? So, but that's what is our interest. So that's why we come to the samples here. So what is the samples here, right? So let's see. Okay, so the samples here. So let's see what is our definition of samples here. Okay, so the samples here is tell us is like, oh, so here, okay. Okay, so here, the samples here. Okay, so the samples here, let me kind of get some space here. So I have some space. Yeah, so I can have some space later, right? Okay, so Just like we said, the population depends on what we want to study, right? So sometimes the population can be pretty big. So if you said, I want to find the average family income for the Dallas area, so that means you need to check every Dallas families, right? That is a huge population. So this is come to record is the samples here. So the idea of a sample, because of a population is too big, so sometimes I can do it, right? So it's impossible to take the sample of the, to check every family in the Dallas area. So that means the sample is what? Is a proportion, right? So here's the keyword. So sample is a proportion, or we say it's a subset of this large of the large of this population. And hopefully, when I take the sample, I can know how to do that correctly. Then we will study these proportions, right? So we will study these proportions. And then from this proportion, we will gain information about the population. So like we talked about, if I want to find the average income for the whole Dallas family, it's such big a population, so I cannot do that. It's very, very time and the finance consuming, right? So it's like it will probably cost a lot of money to do that. So that's why I said, hey, let's take a sample. Let's take a subset. Maybe I can take 100 families, right? Then I will find each family's income, annual income. Then I will average them, right? So hopefully my sample is very representative of the city of Dallas. And then my sample average can give me the information about these populations. All right. So that is what we call the samples here. You want to take a small proportions here. And that's why in our next unit, we're going to talk about how do I take good samples here. That will be in our next unit when we finish the hypothesis testing. And then we're going to take a look, how do we do a correct survey? How do we get the good samples here? Okay, now let's take a look. The next definition, we talk about statistics a lot. So what is statistics? All right. Okay, so this is a very, very important definitions here. So we said statistic. What is a statistics? So we said statistics here is a number. So here is the keyword. Statistic is calculated by the sample data. So let's represent the property of that sample. So for examples, right? So we talk about, we say, well, I want to find the average family income. So I take 100 families. And then I find each family's annual income. Then I average this 100. So the average I get from this 100 is, we call this a statistic. All right. So the statistic is from what? Statistic is from the samples here. All right. Okay. So it's a kind of a important concept. All right. So the statistics is, so a lot of people have the, the trouble. We heard the statistic a lot, but what exactly is a statistic? Sometimes some people, they have trouble to understand that. Okay, so now let's take a look at what is another parameters. So what is the other definition? What is meaning when we say a parameter? All right, so parameter, so what is the parameters means here? The parameters is a number, is the property of what? Is the populations here, right? So the keyword is here, parameter is related to the population. So for examples here, so we say, I want to see what is the average income for the whole every families in the Dallas area. So the parameters here, that means that this one's here is the averages, right? So it's the average of the whole population, right? So if we want to do that example, so that's the the parameter, that's the number we are interested. Just like we say, typical, we don't get it. So that's why we say we're going to use a sample. That means if I take 100 families, I find the average income for this 100, I get a number. So this number could be, for example, is like 52,000, right? So this is what we call is the samples. Right? So the population parameter, that's the parameter I'm interested in, is the average income. But the typical, I don't get it. So that's why I want to use the sample statistics to try to estimate, right, the parameters here. So here, this is a very important relation, right? So if your sample is represented, so the statistics, right, will give a very good idea what is your parameters looks like. All right, cool. Okay, so now let's take a look at the next ones here. So next one is, that's what we call it is representative sample. What is representative samples here? So the representative sample, okay, so let's take a look. This is what we mean the representative sample. Okay, so in here, we said, okay, so in here we said one of the main concern in the field of the statistic is how accurate a statistic to estimate a parameters, right? So like we did from the previous, we said we typical want to use a statistic, and the statistic can get very good information about the parameter if you do a good samples here, right? So that's why we say we typically want to estimate. So the accuracy really depends on how well the sample represent the population is kind of makes sense, right? So the sample must contain the characteristic of the population. So you cannot have a biased samples here. So for example, here, so like, for example, you know, like if you take your dog to the dog park, right? And then somebody come to the park and ask you, say, hey, the city have a space there. They were thinking about to put a library there or to put a park there. So you probably, so if you do a survey, if you take a sample just for the people come to the dog park, most often, what will they say? They will say, I think I like having another park, right? So for my dog or for the other people's dog, I don't need the library. I cannot bring my dog to the library, right? So if you just take the sample from the people there, so what happened? You have a biased sample, correct? Because your sample doesn't represent the whole population there. So the best ways here, you might want to take a sample in a different space, different places. So that, you know, that sample you need to contain the characteristic of your population. That means you cannot have a biased sample, only cover certain part of the population. Then what if you do that, then whatever your statistic provide will not be a good estimator for the parameter. Is because it's not representative. So because this is so important, right? So we're going to have a separate unit to talk about what type of the sampling we're going to use and what could have the issues with that. Good. Okay. So the other things here, so we talk about is the variable. So you will hear when we talk about the variables here. Okay, so what is the variable? That's what we use this term a lot in our courses here. So let's make sure we understand the variable. So a variable here is like sometimes, you know, we said, we use the capital X and you know, you can use the capital letter like X, Y, Z, and then there are certain characteristics, right, of your, you know, you are interested is in your populations here. That's why it's kind of like the parameter. So if you say I'm interested in the I'm interested in the average of the income for the whole Dallas area family. So you can define the variable X here. You can say, hey, this is the average incomes, right? So you can do that, right? So it's just kind of like the variable, just like you learn in the algebra, is variables here, and they have the, it's a characteristic of what you are interested in the population. Okay, so now the last thing here is the data, right? So what is the data here? So here is our definitions for the data here. So let's see here. So what is the data here? Data here is the actual value of your variables here, right? So they may be the numbers or they may be the words here, right? So if the datum is a single value, let's say if you only one number, so you one data points here. So for example, here is the actual data, right? So like, for example, you say, hey, X here is the weight. Okay, so it's the weight for all the students in the universities, right? So what is your data will looks like? So data is actual numbers, right? So if X is the weight, so the data of the X will be what? You could have 96 pounds, 121, 105, 201, and like 111. So those are, we call it is the data here, right? So those are the few terminologies you will hear throughout these courses here, right? So you hear me talk about the statistic, you will hear me talk about the parameters here. Okay, let's take a look at one example to see we fully understand, this definition. So now, okay, so let's read very carefully. So now we can know whether we capture the word or not. So let's say a study was conducted at a local college to analyze the average cumulative GPA of the student who graduate from the last year, right? So it's from the local college, and the student graduate for all the students who graduated from the last year. Okay, now what do we try to analyze here? We try to analyze the average cumulative GPA. Okay, so now let's take a look, see here. So we said we have these possible choices here, right? So we said, what is the my population here? All right, so here, so the population is the point you want to study. So you read this problem, they say a study was conducted at a local college of the students who graduate. All right, so what is the answers here? It will be F here, right? So it's all the students who graduated from the college last years, okay? So part A is not right. Part A is all the students who attended the college. No, it's not attended the college. So it's we are interested is the who graduate. Okay, statistics here. Okay, so remember the statistic is what? Statistic is a sample, right? So related to the sample. That means you need to take a sample for that. Maybe you, instead of check every student graduate, you take a sample for 10 students or 20 students. So let's see what we interested, okay? So then in here we say, is here, let's see here, the average cumulative GPA of the student in the study who graduate from the college last year, okay? Okay, so now that's why we said, okay, so what is my statistics here? It will be what? It will be, because I'm looking for is the average GPA. So this is what? This is G's, right? So let's read the G to see it's right or not. So this is G, see here. So it's the average cumulative GPA of the student in the study who graduated from the college last year. Right, so I'm taking a sample, I'm taking certain I'm taking like certain number of the students. So that's why in here, the key things here is because I want is cumulative GPA and of the students in the study. I did not say all the students, right? So it's only the students in the study. I did not say the student who all the students who graduate. All right, so the G, so the, you will say what is this, right? So this is a group of the students who graduated from the college last year, randomly selected. That's not what the statistic is what you get from your sample, right? Okay, now let's see what is a parameter. Okay, so parameter is what? Parameter is what I'm interested for the what? For the populations, right? So now see here, now I said that what things I'm interested in is the average cumulative GPA for all the students who graduate. So which ones here will be? This one will be, so will be the E's, right? So it's the average cumulative GPA of the student who graduated from the college last year. So everything in the who graduated from the college last year, that's the whole population, right? Okay, so now the sample, remember, is a small portion. That's, I don't want to say small, it's a portion of the population. So let's take a look at what is the samples here. So the sample is these, right? So you say a group of the student. Okay, so the key things here is a group of the student who graduated from the college and randomly select this group. So in order to be a representative samples, right? Okay, good. So now the variables here, the variable, remember, represent the characteristic I'm interested. So what I'm interested is the average cumulative GPA. So what is my variables here? So it's the cumulative GPA once the student who graduated from the last years, right? So that will be my B, is the variables, represent the characteristics. Then what is my data? So here, this is my data, right? So it's a true, the real values here, okay? So that is so in this example, so I think we can get a good understanding. So what is the definition of the population and the sample? Okay, so basically if you want to group it, right? So the Huamin group, these two, like a population versus sample, right? One is the whole big group, one is the small proportion. Then the next things here is we said a statistic and the parameter. These two kind of belong to the same idea. That means the parameter represent what you are interested in, the value you are interested in the whole population. Then statistic is the value you get it out from the sample. So typical we want to do is use the sample to get you some ideas, right? Then the variables and the data, they kind of belong to here. So variable is represent the characteristic. Then the data is just whatever the real numbers you are interested for this variable. You go to collect the data, could be 20 data points, 40 data points here. Okay, that's it. And this is our introduction lectures. And then our next lecture, number 2, we're going to formally start what is a testing hypothesis. That is our first inferential statistics. We're going to talk about how do I make a correct decisions. Yeah. Okay, it's nice to talk to you and looking forward to talk to you in our lecture number 2 here. Okay, bye-bye.